Okay, from the worksheet question 17, question 17 is about something called gradient. There will be a question on this definitely. So they start by giving you a function. And it's e to the xy minus y squared. They also give you a vector. -5. And you're given a point. 2, 2. They ask for rate of change and the following directions. So before we do the directions, we need to do the gradient. The gradient is, we find the derivative for this in terms of x and in terms of y. In terms of x would be itself. The derivative of the exponent would be, in terms of x, constant x would be the constant, and this is a constant derivative 0. In terms of y, it would be itself. The derivative of the top in terms of y, a constant y, or constant derivative of this is 2y. Then you find the gradient at the point 2, 2. You plug 2 and 2, it would be e to the 0 times 2, e to the 0, and here would be 2 minus 4. That's a 2 and a minus 2. Once you do this, the first question was, what's the gradient if it's in the direction of the vector? So the first thing is if it's in the direction of the actual vector. First of all, you need to find the normal vector. The normal vector is, you take it, you divide it by the magnitude. The first one squared, the second one squared. Square root of 169, 13. So now the normal vector, 12, 13, -5, 13. If you want to do the gradient of what we found in the direction of the vector, it's just dot multiplication. 2 minus 2, which is this, times 12, 13, -5, 13. 24 over 13, 10 over 13, 34 over 13. So after you find the derivative and the gradient at the point, this is a vector, of course. If it's in the direction of a certain vector, you normalize it, you find the normal vector, and it's just dot product. What if it's in the direction of largest increase? So now the direction is largest increase. In the direction of the largest increase, it would be whatever the gradient is, and you can also find the magnitude of this. 2 squared minus 2 squared, it's root 8. Because it's the largest increased. If the question was largest decrease, it would be the same thing, but minus. So minus of this, which is eventually minus of root of 8. That's if it's in the direction of the largest decrease or the minimum. So maximum, you do this. Minimum, you do the negative of this. C, direction of angle pi over 3 with the x-axis. So, your vector in this case, if it's angle with x-axis, would be cosine of the angle, sine of the angle. So it would be cosine of pi over 3, sine of pi over 3. That's half root 3 over 2. Then you do a dot product between this and the gradient. That's 1 minus root 3. This is if they ask you angle with the x-axis. Now, if they ask you angle with y-axis, for example, and let's say that the angle was pi over 4, if it's with the y-axis, you do the same thing. Let's say it's pi over 6. If they ask you for with the y-axis, you take pi over 2 minus the given x. You do pi over 2 minus the angle, and this is the one you plug into this. So if it's with the x-axis, you take the angle itself. If it's y-axis, you take pi over 2 minus angle, and then you do it. Okay? What if it's a direction with the angle with gradient? Angle if they ask you with the angle with the gradient, all you need to do is this. The direction in this case is going to be, you take the value of the gradient, cosine theta. That's if it's angle with gradient. So the value of this, you square the first one, you square the second one, and cosine pi over 4. That's root 8. Cosine pi over 4 is root 2, so you have root 8 over root 2, which is root 4, which is 2. And finally, E, what if they ask you along the vector 1? Since it's a constant, the direction in this case would be 0, since it's constant. So since the level is constant, you don't need to do anything, level is 0. I'm gonna go to the midterm and find the question similar to this and do it. If I go to the midterm, I think in the last page, question 16A and B. So question 16. So the function itself, this is midterm. The function in terms of xy is x sine xy at the point 2 and pi over 2. So, in the first thing, you need to find the gradient in A. They want you to find the gradient. So the derivative of this with respect to x, derivative of this with respect to y. If we do it with respect to x, we have to consider dot product. Derivative of the first one times the second function. Derivative of the second function, which is cosine xy. Derivative of the inside, a constant x, would be the constant times the first one. That's if you do it with respect to x. If you do it with respect to y, derivative of this, x is a constant, so it would be cosine xy times the inside, and it's x. And then what's the gradient at the point 2 pi over 2? Plug it here, pi over 2 times 2, that's sine of pi. That's cosine of pi times pi over 2 times 2. Here it would be 2 cosine pi times 2. That's 0. Cosine of pi is minus 1, so minus pi. Here minus 1 times 2 times 2 minus 4. So the result of the gradient is negative pi, negative 4. So I'm gonna erase this. So the gradient at the point 2 pi over 2 is negative pi, negative 4. Then the first question is if you do it in the direction of a vector. I told you, if you're asked to do it in the direction of a vector, you take the normal of the vector first. And the normal of the vector would be this over the magnitude. The first one squared, the second one squared. This is negative 1, negative 1.5. 1 plus 1 over 4 is 5 over 4. So this is like negative 1, negative half. Root 5 over 4 would be root 5, and root 4 is 2. So basically, if you have this divide half, you're just like multiplying by 2. So to cancel this, you can just multiply this by 2. This is minus 2 minus 1 over root 5 over root 5. So once you have the normal of the vector, you do cross multiplication and that gets you the direction. So now we need to do the cross multiplication between minus 2 root 5, negative 1 root 5 with minus pi minus 4. First time first, 2 pi over root 5. Second time second would be 4 over root 5. The answer 2 pi plus 4 root 5. This is the result of if it's in the direction of a vector. Now, if you're doing it with an angle pi over 3, positive x, so if it's with an angle with x, so you don't need to go pi over, if it's with the y, you go pi over 2 minus. So it's the angle, so we need, the vector in this case would be cosine theta, sine theta. Cosine of pi over 3, sine of pi over 3. Half root 3 over 2. So we do the half root 3 over 2 times the one we found, the gradient, which is minus pi minus 4. This times this would be pi over 2. This times this would be 4 root 3 over 2. So negative pi, negative 4 root 3 over 2. You could just leave it as it is. You could try and simplify it, but I think you're good if you leave it like it is. Good? So nothing special about the gradient. There was a question also, so we did the gradient direction question 17. We also did the one from the midterm. There is question 20, the last question in your worksheet. You consider you're given a function, question 20. X squared y. And you're given a point, 1, 0. And you're given a level C. Function equals 1. Verify that the P on C. So first of all, make sure that this point is here. Well, if you plug it here, 1 squared plus 0 would be 1. So yeah, the point is on. Find the derivative for this at the point. So gradient. Derivative of this with respect to x is 2x. Derivative of this with respect to y is 2y. What is this at 1, 0? It would be 2, 1. So we found the gradient. Now, sketch. You need to sketch this curve. Now, to sketch this curve, you have this function, x squared plus y at level 1, making 1 minus x squared. You know, if this is x, this is y. Negative x squared is letter n, and the 1 makes it start from 1. This is the point 1, 0. And the gradient pretty much means the tangent of the curve in this case. So the tangent of the curve is the 2, 1. So that's another way of asking the gradient. And remember, gradient is basically the derivative in terms of x, in terms of y, and you plug the point. Okay. we go into finding derivatives and stuff. So I'm gonna do the questions from so I'm gonna erase this first of all. So we'll do the easy derivatives first. So easy derivatives, let me see here. Okay. We'll start with question 16. Worksheet, question 16. The function in terms of xy is x squared y cubed 5x y squared. So you're finding fx or derivative of x with respect to x. You could be asked to find derivative of y. So derivative in terms of x, so y is a constant, so x squared derivative to x. Y is a constant, so 5y squared is a constant, so a constant in front of x would be the constant. So that's the derivative with respect to x. If you do it with respect to y, now x is a constant. 3 down here. Now x is a constant. 2 down would be 10xy. That if you do it the straightforward, no chain rule involved, no implicit differentiation, straightforward. I'll go to your midterm and see the straightforward sorry. We go to a midterm and we see the straightforward question. So for example, question 10. Question 10, they're all straightforward. We start with A. You're trying to find the second derivative in terms of x for this. Means you find the derivative with respect to x the first time. Derivative of this with respect to x would be itself times derivative of the exponent. A constant would be 2xy. To find the second derivative of x, you differentiate this again. Again, this is question 10 from the midterm. Here we have to do dot product. Derivative of the first one with respect to x. So this is the first one. Would be itself times the derivative of the exponent. This is derivative of the first one times the second one, plus the derivative of the second one, which is 2y, times the first one. This is if you do it, and you can simplify this and say this is like 4x squared y squared ex squared y 2y ex squared y. This is if you're finding the derivative with respect to x 2 times. Let's do question C, or B, sorry. Or, because of the time limit, I'm gonna stop this video and question 10b will be part of my next one.